Hello, students. So, today, this lecture and the following couple of lectures are all about the following formulas. So these say what happens when you add two angles together and try to take the trig function. And you should think of them as being analogous to some things that we know about, say, exponentials. You know that an exponential raised to the power a plus b is equal to 2 to the a times 2 to the b. The point is that this says if you know 2 to the a and 2 to the b, then you know 2 to the a plus b. And importantly, that quantity that you get for 2 to the a plus b is not the same thing as 2 to the a plus 2 to the b. It's not 2 to the x is not an additive function. You can't add inputs and expect the result to be the addition of the outputs. The same is definitely true for angle addition. If you add two angles together, you don't expect their cosines to add, but you do expect something like that to happen. And in fact, here are the formulas you get. The actual formula, the derivation of the formulas, the reason that they're true, is an extra credit posted for today. So let's get started. The cosine of a plus b is always equal to the cosine of a times the cosine of b minus sine of a sine of b, while the sine of a plus b is given by the sine of a times the cosine of b plus the cosine of a times the sine of b. Neat. And again, that's a formula that I won't derive in this lecture, but a derivation does appear in the extra credit, which, well, once you know what happens for cosine, you can probably figure out what happens for sine. Moving along, the cosine of a minus b. So I think I even want to take a moment and figure out what that should be, given this formula. So if you know this formula, I claim that you can figure out that formula easily enough. And you can think of this as an invitation to say the formula for the cosine of a minus b you don't necessarily need to remember. If you remember the formula for the cosine of a plus b and how cosine and sine behave under a negative sign, then you can reinvent it on the spot. So let's do that. Let's try to compute the cosine of a minus b. So what is a minus b? It's the same as a plus negative b. So this is the same thing as the cosine of a plus, and maybe for emphasis, I'll do a little bit of clever color choices, negative b. Neato. Now I see the sum of two things. This formula right here says that whenever you see the cosine of a number plus a number, the result is the cosine of the first number times the cosine of the second number minus the sine of the first number times the sine of the second number. So let's just write that down. That will be the same thing as, using that formula, the cosine of a times the cosine of negative b minus the sine of a times the sine of negative b. Oh, well, I know what happens when I stick a negative sign in front of an angle inside of a trig function. I know that cosine is an even function and sine is an odd function. So this negative sign I can just erase because cosine is even. That negative sign, well, the function sine is odd, so that negative can pull out front, where it'll cancel with that negative sign. So, writing that out, this will become the cosine of a times the cosine of b minus the sine of a multiplied by negative, oh, maybe that negative sign should be green because it's like the same as the previous negative sign, times the sine of b. Right, so this negative sign has moved out front to become that negative sign. And, well, in this second term, I see negative times a negative. Those negatives will cancel. So that's what happens when you multiply two negatives together. And you wind up with cosine A, cosine B, plus sine A, sine B. So the cosine of A times the cosine of a minus b is equal to the cosine of a times the cosine of b plus sine a sine b. And, well, I bet you could do something really similar for this function sine, the sine of a minus b. And I'll just write out what you wind up getting. You should take a moment and do the same algebra as happened right here in that situation. So you should pause and do that. I'll write down what you get right here. You wind up with sine a cosine b minus cosine a, let's include the parentheses, sine b. Alright, so the main point of this lecture isn't just that, it isn't why these formulas hold. Rather, it's that you have these formulas. That means that if you can write down an angle that you're interested in as a sum of, or difference between two angles that you understand, you can work with that number. For instance, pi over 3 minus pi over 4 is equal to pi over 12. Go ahead and take a moment and check that. For those of you who feel very weak with fractions, I'll do that. Pi over 3 minus pi over 4. You want a common denominator, so it looks like the common denominator is 3 times 4 is 12. That will be 4 pi over 3 times 4 is 12, minus 3 pi over 3 times 4 is 12. Yeah, that's equal to pi over 12. So if you wanted to compute the cosine of pi over 12, then as soon as you know that, notice this fact. You can say, well, the cosine of pi over 12 is equal to the cosine of pi over 3 minus pi over 4. Now, we can use this formula. No, not this formula. So I'll take that formula, I'll take this a and plug in pi over 3. I'll take this b and I'll plug in pi over 4. And I will wind up with the cosine of pi over 3 minus the pi over 4 is the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. So that's just what the angle addition formula tells you. But all of those numbers, all of those angles, pi over 3 and pi over 4, those are all angles that you see on the unit circle. So those are trig functions that you know. The cosine of pi over 3 is 1/2 times the cosine of pi over 4 is root 2 over 2 plus the sine of pi over 3 is root 3 over 2 times the sine of pi over 4 is the square root of 2 over 2. So you wind up with the square root of 2 plus the square root of 6 all over 4. Neat. So that means you can make new computations given old computations. I want you to do the following example. So I'm going to say some words and then I'll explicitly say when to pause. I want you to compute the sine of pi over 12. Okay, do it. Pause the video and compute that. Alright, you did that. Let's talk through the computation. The sine of pi over 12, just as above, will be the same thing as the sine of pi over 3 minus pi over 4, because pi over 12 is equal to pi over 3 minus pi over 4. Using now this formula, this is the same thing as the sine of a times the cosine of b minus, because of this minus, cosine a sine b. Cosine pi over 3, sine pi over 4. And again, like you just did, these are all numbers that you see in the unit circle. Computing those, sine of pi over 3 is root 3 over 2 times cosine of pi over 4, root 2 over 2, minus cosine of pi over 3 is 1/2. Sine of pi over 4 is root 2 over 2. That all walks out to root 6 minus root 2 all over 4. And let's do a quick double check. Here is a computation for cosine. Here is a computation for sine. Let's see, an angle of pi over 12 is in quadrant 1, so both of those should be positive. And indeed they are positive. Right? Positive plus positive is positive divided by 4, still positive. 6 is bigger than 2, so this difference is positive. Divided by 4, still positive. Let's use a machine to get decimal approximations for each of those. And then let's use those decimal approximations to see if the Pythagorean identity holds for these angles. So let's do that. Using a machine, square root of 2 plus the square root of 6 is approximately 0.966. Similarly, the square root of 6 minus the square root of 2 all over 4 is approximately 0.259. Taking those two numbers, squaring them and adding them together, let's see what we get. And remember, those are just approximations, so we'll only expect approximate. 0.966 squared plus 0.259 squared. Let's write down what that is, and it should be pretty close to 1. And indeed, a computer-aided computation returns 1.000237. That's 1. That I only know this number up to 3 decimal places. I only know that number up to 3 decimal places, so I'll know the squares up to like 6 decimal places, but then I add them together. So yeah, that's within the error bands that I anticipate. Some more examples for you. So here's what I want you to do. Realize 5 pi over 12 as a sum of two angles that appear on the unit circle, and use those to compute the sine and cosine of 5 pi over 12. Okay, pause the video, do that. I'll keep on talking. So we want to understand 5 pi over 12. So first, let's try to find a couple of angles that add up correctly. Come on. Here we go. So 5 pi over 12, let's try this. Pi over 3 plus pi over 4. Let's see what we get. So let's see, we'll get 4 pi over 12 plus 3 pi over 12. Oh goodness, but that's 7 pi over 12. We are 2 pi over 12 too big. So pi over 6 too big. Oh, neat. Well, I can take that and reduce it by pi over 6 to get pi over 6. And I will now see pi over 6 plus pi over 4 is equal to, again, common denominator is 12. That's good. 2 pi over 12 plus 3 pi over 12. Yes, that is indeed 5 pi over 12. Checks out. So if I want to compute the cosine of 5 pi over 12, I will use that fact. Cosine of 5 pi over 12 is equal to the cosine of pi over 6 plus pi over 4. Using the angle addition formula, so scroll up a little bit, you see it up there, cosine A cosine B minus sine A sine B. So it'll be the product of the two cosines, cosine pi over 6, cosine pi over 4, minus sine pi over 6, sine pi over 4. Writing that out, the cosine of pi over 6 is square root of 3 over 2, times the cosine of pi over 4 is the square root of 2 over 2, minus the sine of pi over 6 is 1/2, times root 2 over 2. Walk that all out, it looks like you get root 6 minus root 2 all over 4. Now, do the same thing for the sine of 5 pi over 12. Well, it's the same computation, which you guys have also already done, so I'll be a little bit quick. Sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. I am using this formula right here. Neato. So, write down what all of those are. Sine of pi over 6, looking at the unit circle, that's 1/2 times root 2 over 2 plus cosine of pi over 6 is root 3 over 2 times sine of pi over 4, root 2 over 2. That's root 2 plus root 6 all over 4. And let's just go ahead and circle those because it's getting a little bit messy. I'm going to use these circles to also do some color coding. So between the the answers for the angle that you just walked with and the angle that we did before, pi over 12, notice there's some similarities. This cosine is the same as that sine. This sine is the same as that cosine. So why is that? Let's figure that out. Oh, well, here's the reason. What is 5 pi over 12? Well, 5 pi over 12, you could also realize that as pi over 2, 6 pi over 12, minus pi over 12. This operation, where you replace an angle by pi over 2 minus that angle, that just interchanges two technical words. Swaps cosine with sine. So yeah, you expect the cosine of this angle to be the same as the sine of that angle, and the sine of this angle to be the same as the cosine of that angle, and indeed it was. Oh, but cool, let's actually just check this. We know, and we just reminded ourselves of the fact that the sine of pi over 2 minus x is the same thing as the cosine of x. But over here, I see a difference between two angles. Angle subtraction should have something to say here. Let's see what it says. So the sine of pi over 2 minus x will be the same thing as the sine of pi over 2 times the cosine of x minus the cosine of pi over 2 times the sine of x. Now pi over 2, that's the angle which points due north on the unit circle. So this sine of pi over 2 is 1, this cosine of pi over 2 is 0. Making those substitutions, we see that this is equal to, oops, that is not what I wanted. That is the highlighter. Is equal to just the cosine of x, which is what we expected. So you can use the angle addition formulas to recover all sorts of previous identities. And, well, it's probably quicker to just remember this fact than is it to remember that you can do this, but it's useful that it checks out this way. Cool. So I'm going to stop the video soon. I'll move on to the next one. So we can do all sorts of other tricks with this. Let's say you know the sine and cosine of a pair of angles. Then the formulas above say that means you know the sine and cosine of the sums of the two angles. But if I tell you the cosine of two different angles, you can figure out the sine, right? You can use the Pythagorean identity to get that. So you can use that to figure out the cosine of a sum of two angles, given just what the cosine of each angle is, and maybe some quadrant information. You can also explain other things in terms of addition, right? If you can understand 2 times an angle as an angle plus itself. So we can get a formula for the cosine of 2 theta. We'll do that probably in the next video. Finally, you'll notice that we walked out angle addition for sine and cosine. There are like 6 other trig functions. Maybe the one that I'll emphasize is tangent. We'll do some computations with that. And then we'll call it a day. Cool. I'll see you in the next one.